I'm excited about 3 great presentations that we have. We're officially starting the 10 a.m. session. We're going to be talking about generative AI's impact on video production, and a novel method for constructing knowledge graphs from unstructured text to improve news data management. And then we'll welcome Eric back to talk about AI and animation. So first, we're going to start with Brent Rabowsky. He works for AWS. He's worked in the field of AI at Amazon for almost 10 years, currently manages a team of AI and data specialists for AWS, and the team's focus is on media workloads and has previously been a speaker and author for SMPTE and is a technical editor for AI books for O'Reilly and Packet Publishing. So please welcome Brent. Thank you.
All right. Thanks, everyone. Appreciate your coming here today. So I'm going to talk about a very specific topic about applying generative AI to media workflows. So I'm going to mainly address video generation models, which are one of the most promising tools to apply to media. And so I'm going to start off with what I think is one of the most successful examples of the use of these tools, short film called Airhead, and I'm going to talk about the reality of the work that went into making it professional. Then I'm going to talk about the current state of the art, where we're at with these models and their usefulness. Then I'm going to talk about one of the key techniques for getting the most out of these models, or any Gen AI model, which is prompt engineering. Then I'm going to talk about how you can apply these models in post-production. You saw a little of that with Roger's talk. Media search is a very important capability. And then finally, I'll dive a little bit into how these models are trained and how they work. So you may have seen this. You won't be able to hear the audio, but I just wanted you to get a sense of the visuals for this short film if you haven't seen it. It came out earlier this year. So, but I want you to pay attention to the visuals. I'll just play a few seconds of it for you. And again, just focus on the visuals a bit. This is a film about a character whose head is a balloon. So it's very well done, in my opinion. And it took a team of 3 people about 2 weeks to do it.
Quite obvious what that thing is.
So there you can see the central concept of the character, and that's what the film is based around. All right, so I think that gives you a pretty good flavor. So you can see it's quite professional looking, very well done. But behind the scenes, there were quite a few issues. So one of the key issues here was the fact that for every 300 clips that were produced, only 1 was usable. So, of course, that's a huge amount of waste, and behind the scenes, there's GPU hardware running these models. So, obviously, that's a key limitation. And then the models have improved to a point where there's a lot of consistency of objects within a scene, but between different clips or shots, you'll notice the character looked a little bit different. So that's another limitation currently you see with these models. And then these models have inherent randomness. So they're stochastic, so they won't produce the same result for the same prompt every single time. And what happens is that typically in post, you have to use a huge amount of editing. So for example, even though the producers wanted the character to have a balloon with no face on it, sometimes the model with a mind of its own just slapped a face on it, which they had to edit out in post. So there's quite a bit of work. And so again, the key limitation that the producer stated was just the lack of sufficient creative control over the model output. This is a situation that's improving, and I expect over the next year there'll be substantial evolution. But that leads me to my next point. So what are the feasible use cases now? So I think there's actually quite a few, whether you're an indie or a producer of commercials. And so ads is one of the key initial applications that we already see. And so I'll play this video for you now. So this is actually probably the first large-scale production use case of video generation. So Amazon Ads allows advertisers to create their own videos using AI. And so this is what it looks like. Basically, you supply a product image and the AI will animate it. So you can see this is very straightforward application. It's not super dynamic, but it gives you, it's definitely more engaging than just a static image, right? So besides ads, and I think we'll see quite a bit of applications and commercials, and of course, some of you may have seen the infamous Toys R Us commercial that came out earlier this year as well. There's a lot of potential uses in pre-production. So we've already seen some of those, animatics, other visualizations that don't require very high resolution necessarily, just to give a director or creative's idea of what something might look like. Then in terms of production itself, B-roll, second unit. So if you want an establishing scene of a castle in Spain, you can certainly ask a model to produce that and have pretty good results without having to pull stock footage or send a crew over there. And then post-production editing, as we saw earlier, is one of the key use cases that is practical now, more or less, and VFX as well. All right, so a key consideration when you're choosing one of these models, and there's several commercially available right now with many more on the way, is what kind of input mode is available. So the first video generation models were text-based. So you would supply a text prompt describing the scene and it would produce an output. But now the trend is towards multimodal. So you can supply not only text, but also potentially an image or even another video. And the future is basically anything to anything. So an example would be supplying text prompt and then getting out a video with audio also synced to it. So we'll see that much more in the future, I would say next year. All right, so I wanted to give you a concrete example here. So I'm going to start the top video for you. And so this is just kind of a standard drone shot of the Hawaiian jungle, right? So not very dramatic. It's a pretty short clip. And then what you can do is also supply a text prompt to modify that video. So this is basically an editing example. So you could say, hey, I would like to have kayaks in the water there. And so, oops. So in the bottom video there, you can see the kayaks have been added. And you can perhaps see that they're bobbing up and down on the water. So that's a very straightforward application of a multimodal input for one of these models, both text and video. All right, so text plus image is, if you're mathematically minded, it's like the inverse operation of the video input. So with the image input, you basically supply an aesthetic with the input image and you animate it, whereas with the video input, you're supplying animation and then you're changing the aesthetic of it potentially. So in this example, I wrote a prompt about a live music festival, and then I supplied that to the video generation model with some additional prompts specifying actions. So I'll play that lower video for you, and I think you'll see it did a pretty good job of capturing the additional prompt language, the dancing, the flashing stage lights. I'll play that again for you. So again, the models work pretty well at these types of applications, but the range of animation at this point is still quite limited. So it's not really going to go outside the frame of the input image or extrapolate to anything beyond the frame or do any exceptionally dynamic motion. So you've seen a few prompts already, and the prompts are really what allows you to apply the creative control to the output. So there's a big difference here between video generation models and other types of models you've seen for text generation. And it comes down to the requirement of specialized knowledge if you want to produce a professional quality video. So if you just have a text model, you can ask it, what team won the Super Bowl in 1983, or summarize this document for me. You don't really need to have any specialized knowledge. Though, of course, with any kind of model, prompt engineering is necessary to get the most optimal output. But if you're trying to create a professional video, you have to have a wider base of knowledge. You can't possibly produce a professional video, something that reflects your creative vision, unless you do have that kind of background. And so what I've seen over the last year is a trend towards enabling users to apply the language of cinematography when using these models. So I'll show you some examples of that. But first, in terms of what those elements of cinematography are, so I think different experts would have a different list perhaps, but I think most of us could agree that the elements you see here are the key elements, like, for example, camera placement and movement, shot composition and size, focus and depth of field are really critical as a storytelling technique. And then lighting, of course, has been a crucial storytelling technique in filmed entertainment since the very beginning. And just think, those are only 6 of them. Other people would say, type of film stock and all these other parameters and elements. And just think of all the different combinations of those elements that you have to consider when constructing a clip. And then besides these, there's all the rules of cinematography regarding motion of the characters, for example. So it's just a lot of background knowledge to take into consideration. So again, I'm going to show you another example of what I mean here. This is a relatively simple example, but it's basically a tracking shot. So let me play this video for you. And so you can see that, I'll play that one more time. You can see that the model did a pretty good job of capturing what the prompt was asking for. There are a couple of oddities there. For example, the trees on the left side of this street are bare. I don't know why. I mean, I'm not an East Coast person, so maybe that's the way East Coast works. I'm a West Coast person, but so that's, again, something to keep in mind. That's why you get those ratios of 300 to 1 unusable to usable output. All right, here's another example using a couple of other elements. So depth of field with shot size. I'm going to go ahead and play that video for you. Again, futuristic Tokyo street. I think overall the prompt does a pretty good job of capturing, or the model does a pretty good job of capturing what the prompt was asking for. So I think you can see that so far these models have reached a point where they're doing a pretty okay job of capturing some of these basic elements of cinematography. There's still a lot of work to do. And then that's not to mention the fact that if you're really trying to put together a story, a professional video, there's a lot more that you need to consider. So currently there's some models that allow prompts as long as 1,000 words. So you're starting to get up to the point where people are going to be writing novels as prompts. So, and perhaps that will be the direction it goes. You just input great expectations, the model will spit out the whole movie for you. But we're still a very long way away from that. But still, even with 1,000 words, there's a lot to consider. So how do you organize your prompt and think about it? So one possible template is what I have at the bottom of this slide here. You specify camera movement, establishing scene, and additional details, and that can help you kind of organize your thoughts until you gain more experience and confidence writing prompts. So this particular prompt is one I wrote to be somewhat more complex. I specified where the main character, the toy poodle, is in the middle ground, and the motion, I specified left to right motion. Why did I specify that? It's because one of the rules of cinematography is the fact that for some reason, left to right motion invokes a more positive emotional response from viewers than right to left motion. So again, all these rules can be broken and are broken all the time, but more often than not, following these rules will produce better results. All right, so I'm going to start the top video here so you can see what the model did. So overall, I think the model did a pretty good job of capturing that prompt, but let's try another clip here. All right, so the bottom clip was produced by the same prompt, same model, but as you can see, the results are quite different. So especially the left to right motion is not as pronounced as in the first clip. So again, just think if you're using these models, there's going to be a lot of trial and error as you work through it. So I'm going to talk about some more advanced techniques you can use to manage that in a moment. All right, but first, another key difference with video generation models is that they involve the time dimension. So the other models that you might be familiar with for text generation or image generation are not time dependent. So you ask for a summary of a document, it's the same 5 minutes from now as it is from a day from now, right? So with video generation, you have the time dimension introduces a lot of complexity. So how do we deal with this? So right now, different model providers have different techniques. One of them you see on the screen here, it's called prompt travel, where basically you specify at what frame number or point in time the scene should change. And so this particular provider did it was they provided a prompt body that changes over time and a prompt head and tail, which stay the same or change more slowly during the course of the clip. So that's one way, but another way is what I call prompt chaining, where you just have one long prompt that specifies how the scene changes over time. This basically allows you to request a set of mini clips that are produced of length maybe 5 seconds or a couple of seconds, just so you can get an idea of what the prompt might produce. And this is important not only because of the time you could waste sorting through all, potentially hundreds of clips generated by a model, but also due to the cost. Again, you're running on GPU or some other type of accelerated hardware, so it can get quite costly. So this is another technique that makes video generation more practical and feasible. So up to now, I've kind of talked about, how you might use these models in generating what you might call raw footage that you use in the main production itself. But there's also many post-production use cases of these models. And so for this stage of production, it's not only video generation models, there's many other types of Gen AI models that could be applicable here. So editing, we've mentioned before. Visual effects, I've talked to a number of visual effects houses about how they're experimenting with Gen AI currently. Reuse of content is something that's happening now and is, a super huge potential workload. And then localization is also huge as a current workload, and there are a number of companies offering localization with Gen AI right now. All right, so editing. So probably the most prominent example of doing this is Adobe. And so if you attended a show this year, like NAB show, this was prominently featured in Adobe's booth. And so using the Adobe Firefly model, there's a number of features in there like generative extend, object addition and removal, as well as a third-party video generation model market, so you can pick from different model providers. So I'm just going to play a few seconds of this just to give you a quick idea. Again, there's going to be no audio. All of this is on YouTube, though, so you can easily find it, but I just want to give you an idea. I'm going to speed it up a little bit. So you can see the add object functionality. So again, this is really useful functionality, and it's available right in the near future. So, but it's practical, and again, you can certainly potentially build your own even if you have a very straightforward use case and you have a short clip and you just want to use a video generation model that has a video input mode. So reuse of content is another really important workload for Gen AI. So the goal really is to monetize existing content that you have archived potentially. Examples include social media influencers who have a huge amount of footage and they want to reduce it to a short travelogue or highlight reel. And so here, in order to make this practical, you have to combine two different components, video search and video summarization, both powered by generative AI. So video search, again, kind of building on what Roger said earlier, involves basically indexing what we call embeddings in a vector database. So there's a number of different vector databases out there, and so the vectors are actually numerical representation of a particular frame of video, along with textual information that would be associated with it. So basically, you sample a video, you convert it to feature vectors, which are just arrays of numbers, and then you put them in a vector database where they're indexed so they can be searched. And so then once embeddings are in the vector database, you can just search them with a natural language query. And so, again, I've seen a huge number of use cases. In fact, NFL and Maple Leaf Sports just came out with their solutions. They rolled their own, happened to be on AWS. But there's many different providers. Again, if you walked around something like the NAB show, there are solutions along these lines in many different booths. Video summarization is another really important component of content reuse. So for this one, you're leveraging a number of different Gen AI models. So it's not just a single model. And so also you potentially want to summarize to a short form video. So you're not just creating a text description of the video, you're creating a short video or short form content itself. And again, there's many different ways to do this. There's a number of different vendors who package this all together for you. For AWS, we published a solution guidance, but again, there's also quite a few vendors in this area as well. So you combine those two. And then localization is another area where there's just a ton of different vendors out there already offering different kinds of solutions. Unfortunately, you can't hear the audio here. But in the top clip, Jeff is speaking English. In the lower one, he's speaking Spanish. And just want to quickly wrap up with how video generation models work. So basically, they work by shaping random noise into images, which are then extended in the time dimension. So at the center of these, you see image generation model. It could be a famous one like Stable Diffusion, and then you have various components surrounding it to smooth out the action and ensure object consistency, and to make sure that the clips aren't overwhelming the GPU memory of the hardware. Finally, in terms of how they're trained, again, to produce professional quality video, you want to use professionally produced content. You've seen some examples already, such as a Lionsgate deal that just happened with Runway AI. And it's a very challenging thing to do for many reasons. There's many petabytes of archive data and migrate to a cloud if you're going to do this in the cloud. That you have to prepare a gigantic data preparation pipeline for transcoding to a common format, removing unlicensed elements to avoid IP issues, and then it could take many, many weeks for this to run. So I think that does it for me, and thank you so much for attending. Really appreciate it.
Thank you. Thank you, Brent. I think we have time for one short question. I'm sure there's like a bunch. Anyone have one quick question? It's funny, I was helping with editing this paper and presentation, and, you know, I work for Adobe, and I was like, well, this is true right now, but in 2 weeks it won't be true, and I'm kind of a weird position. So this stuff is changing so fast. It's a great overview, great paper. Please do check it out. And yeah, thank you, Brent.
Thank you.